In the last demo, we analysed, transpiled and deployed the AWS card mainframe application as a Java war package to a local Apache Tomcat instance. In this demo, we're going to migrate the 10 vSAN datasets that the application uses. We will use Probe to analyse the application to construct data migration profiles that we will then execute to automatically migrate the data to a local Postgres database. When we run the application without any data, we will get an error stating that we cannot sign on. Let's use pgadmin to verify that the database is currently empty. We can see there are no tables and there are no views. This is the root folder of where our Probe instance is running, and just so it's clear that we're doing the data migration from scratch, we're going to pull the AWS card application from the repo into this folder. Okay, let's analyze the application with Probe. As you can see, we have no analysis data yet, so let's start the process. As part of the analysis, Probe is extracting metadata from the application assets that describe the format and layout of each of the vSAN datasets used by the application. In less than 10 seconds, the analysis is complete. Now we can see some information about the application programs as well as a list of all the dataset references within the application itself. With all the metadata collected, we're now ready to build the data migration profiles. What is happening here is that Probe is constructing a data migration profile for each of the vSAN datasets. It's also constructing a Gradle script that we can use to perform the data migration. We have the option to execute that script here, but we're going to show you that running from the command line so you can see it working. The Gradle script generated by Probe is going to use Heirloom's data migration framework to migrate each vSAN dataset in the repo to a corresponding relational database table. During the process, we are also changing the encoding of the data from EBCDIC to ASCII and creating additional views of the data. The datasets are relatively small, but as you can see, we have successfully migrated all 10 vSAN datasets in under 10 seconds. Obviously, at any point during a migration project, we can reset or synchronize the data by simply running the Gradle script again. If we take a look at the database now, we can see the new tables. To maximize performance, we store the data as binary objects with additional columns for the primary and any alternate index keys. To make the data accessible to any other application, we also create a view that corresponds to the original record layout. If it's not already clear, we do not need to make any changes to the application code for it to access the data in the database. This is all managed by the Heirloom framework. To illustrate this, let's go back to our deployed application. With the data migrated, we can now sign in. Let's pull up an account record and try to update it. When we make a change to the record, we can see that the program logic is objecting to some of the data, which means that the original data is also wrong. This has been verified on our mainframe, so the application itself is behaving exactly as expected. With the data corrected, we can now successfully update the record. So as you can see, Heirloom has an exceptionally fast and modern approach to migrating application code and data. And although we've chosen to show you the steps in this demo, the entire process can be orchestrated from start to finish. We'll save that for another time. In the next video, we'll look at how we deployed the exact same cloud-native application package to 3 different managed cloud platforms.